And everyone, today's topic is how to find partial molar properties from total properties. So what is this partial molar properties? Let's say I have two solutions, one containing A atoms and one containing B atoms. And if I mix these two, then I will have a solution which contains A plus B atom. Now let's take a property which is volume. Now let's say the volume of A atoms be X in this which we have taken, and the volume of B be Y. If I mix this both, so there would be some increment or decrement in the volume which we will see. So the final volume need not to be X plus Y. It can be greater than that or it can be less than that depending on the interaction of these atoms with each other. And therefore, the partial, if I say partial molar volume of A in this solution, which is given by A bar, so it will be quite different than what I have initially, and similarly for B, it will be different as what I have initially. So this is a schematic or a representation which can show you that how these two solutions can get mixed, and we can obtain the difference in the various property like we saw some in volume. Similarly, we can see change in energy or Helmholtz energy, etc. So if we have the mixing energy together in this mixing process, then how can we find the molar properties from this total? Now we know that the mixing properties can be given as the delta B dash mix can be given as the total property of solution minus the initially what we have. So B represents, let B be the any property here. So initial properties can be expressed in the fragments of the quantities of the species which has been taken. So B naught K into N naught K represent where K is varies from 1 to C, the components which are present which makes the total initial B. Similarly for B dash of solution, I can also represent it in the fragments of solution which can be written as this. Okay, so the total B mix, which is the difference of these both, can be written as this as shown in this equation. So for the convenience, this B dash K minus B naught K can be written as B bar K. Simplifying, we can write this as a delta B bar K because this is the difference between the two properties. So as shown here, B mix equal to summation K runs from 1 to C delta K and K. So this is how the mixing properties can be represented in terms of the species which has been present. So if I differentiate this, so what I get is, so I have delta B mix as K minus B naught K and K. If I differentiate this, so if I open differentiation, I obtain this. And here, as a number of moles of the species will be constant, which is represented by NK. So therefore, this term and this term goes to 0. So there is no difference in mole. So altogether, I can say that delta B mix equal to summation B bar K minus B K naught into D and K. So as we know that delta B bar K minus B naught K is written as delta B bar K. So moving ahead, now for the two species which are only present for the two component species, we know that the delta B mix can be written as B1 bar K X1 plus B2 bar into Dx2. So I am interested in finding B1 and B2 from this because these are the partial molar quantities. So on integrating this, I get delta B mix as delta B1 X1 plus delta B2 X2. But we know X1 plus X2 equal to 1 as these are the mole fraction. And therefore, if I differentiate this, so what I get is dx1 plus dx2 equal to 0. That means I can say that dx1 equal to minus of dx2 because I have to find b1 and b2. So if I want to find b1, then I have to make the all equation in terms of b1. Now by substituting dx1 as minus of dx2 in the upper equation, we get this. So if I simplify this above equation to get this equation, so it will be simply that we mix upon dx2 equal to delta b2 bar minus delta b1 bar. And if I take this to this side and this to this side, so I obtain this equation. Now here I have to replace d2 and x2 can be replaced in terms of x1 as we have seen earlier. Dx2 can be written in form of dx1. So from earlier equation we had delta b mix equal to delta b bar 1 x1 plus delta b2 bar x2. So from here I will find the value of d2, that will be delta b mix minus delta b1 bar x2. X2 is 1 minus x1. Similarly, when I substitute this value of b2 in earlier equation, I obtain this. So we know the delta B mix, we know the species x1 which has been present, and from this we can find out the partial molar quantity. Now similarly, by the chronology for B2 it will be delta B mix plus 1 minus x2 B mix on Bx2. So here when you add this to bar quantity, so that will give you the delta B mix total. But here we have delta B mix which is in G1. So from which we have found out what is the individual molar quantities present inside the total system containing B1 plus B2 atoms.